say that you're ordering T-shirts from a company, and when you order the T-shirts, it's going to cost $10 if you order 25 or fewer. So if X is less than or equal to 25, you're going to be paying $10 per shirt. But now if you order anywhere from 25 to 100, sorry, I got the hiccups. 25 to 100 shirts, now it drops down to $8.50 a shirt. So that's for 25 being less than X, which is less than 100. If you order 100 or more, you're going to get them for $7 a shirt. So this would be an example of a piecewise function, because now I can use this bit of information and see what my total cost is going to be. Well, let's say that it's, I don't know, let's say we're ordering 50 shirts. Well, how would I determine the cost of ordering 50 shirts? Which one of these categories does 50 fall into? The middle one. So for 50 shirts, it would be 8.5 times 50. Someone do that in your head real quick. So $425. Is there a question about that?
Nope.
All right. Cross country season this year, we hosted a meet and we ordered 135 T-shirts, and this was pretty much the breakdown they gave us. So it may have been like 725, I can't remember, but let's just see. 135. So that's 7 times 135. $945. So again, in a piecewise function, just based on where your breakdown is as to what equation you use. Now, that's piecewise functions. Let's look at odd and even functions. By definition, an odd function is where f of negative x equals to the negative of f of x. An odd function reflects about the origin and in a polynomial equation, now not all odd functions are in polynomial equations, but in the case of a polynomial equation, every exponent is odd, and there is no constant term. So an example of that would be f of x equals x to the fifth minus 3x. That would be an example of an odd function, because your exponents there are 5 and 1, both odd numbers. So now the reason there is no constant there, if I did write a constant here like plus 1, so that plus 1 is the same thing as 1 times x to the 0 power, and 0 is an even value. So that's the reason why we say there can't be a constant. If you look at it graphically, let's look at just x cubed. This is f of x equals x cubed. So f of x equals x cubed does something like this, which means, as I said earlier, it reflects about the origin. So essentially my distance from here to here is equivalent to my distance from there to there. And my distance from here to here would be equal to my distance from here to here, assuming that these x values are the negative. Like this would be x sub 2 and this would be negative x sub 2 and so forth. But if I add that constant to it, what happens? Don't write this down because this is correct, but it's not an odd function. If I added 1 to it, it would take this graph and shift it up 1. So you see now it wouldn't reflect about the origin. So there is no reflection there. So that's a little bit of an example of an odd function. The graph of y, if you remember from trigonometry, y equals sine of x. Y equals sine of x, if you could picture that graph, it reflected about the origin, so it was an odd function. An even function by definition, f of x equals to f of negative x. It reflects about the y-axis. And in a polynomial equation, every exponent is even, and constants are okay. So it's okay to have a constant, but then again, think about it. Let's think about this. F of x equals x squared. What do you know about that as far as a graph? What does that look like? It's a parabola, right? And where does it go through? Or where's the vertex of this parabola? The origin, right? So if you got a parabola, vertex is at the origin, then you see that reflects about the y-axis. Now, let's put a constant with it. Let's say we have f of x equals x squared minus 2. What did that do? That took this parabola, that took the vertex and it dropped it down 2. So we're here and we're here, right? So that negative 2, all it did is it shifted it vertically. That had no bearing on the fact about it reflecting about the y-axis. It still reflects about the y-axis. So f of x equals x squared minus 2 is another example of an even function. And of course you can think about this as being minus 2x to the 0 power. And of course x to the 0 power, 0 is an even value. All right,